supervise and support several activities. First, he would lead the LabVIEW implementation effort that we started in summer 2012. And over many months of very hard work with John here, they will restore lab space and redefine some of the lab equipment and as well as inventory. In summer 2013, Dinesh continued to support our efforts with developing an advanced laboratory for advanced courses and to support new design projects. So as a result, he has acquired specific skills in GPS data acquisition, processing, by helping to set up our remote sensing laboratory. My recent conversation with Dinesh indicates that he has not yet made up his mind where he wants to work for, but I think with this set of skills, this should not be too difficult. So this is with great pleasure that we welcome Mr. Dinesh Manandhar to the LabVIEW Free City Council.
Thank you. Thank you. All right. How's everybody?
Awesome.
Good, good, okay. So, again, as Dr. Conley said, my name is Dinesh Manandhar, and I'm a senior in computer engineering. Today, I'll be talking about my senior design on solar charging case, because that's on my background right now. So, today we'll talk about, I'll talk about the reason for choosing my project, my solar design, solar charging case, and I'll also talk about the step that I went through to develop the product as a whole later on the further slides. So before I jump onto my presentation, I would like to ask you a question. Does anybody know how long do we have before we run out of fossil fuel that powers on our electricities and all? Anybody?
Yes.
No? All right. According to CIA, it's about 53 years. So we have about 53 years before we run out of our fossil fuel at our current peak consumption level. Also, BP says we will run out of oil in 40 years if we keep our trend of using the oil, which is pretty scary. So what can we do next? That's my main motivation, is to use the renewable source of energy to apply in our daily uses, such as electric or hybrid vehicle out there in market, or how about solar energy? As we all know, we all use cell phones. Looks like everybody has one. So I thought that would be a good thing to work on, because we would be saving tons of energy using solar energy if I could be able to use solar charging case. So now, talking about solar energy, what's available? With these maps, it shows how much solar radiation we get per month. This is the map that shows how much solar radiation we get in January, and this is in July. This is a typical winter, and this is a typical summer. So in winter, it looks like we are here. Massachusetts alone is getting about 2 to 3 kilowatt hour per square meter per day. And in summer, it looks like we're getting a little more. It's about 3 to 4 kilowatt hour per square meter per day. So why am I talking about this? Because an average household in the United States uses about 900 kilowatt hour a year. A month. Which means using our solar energy, we could fulfill the requirement of electricity that we consume every day on our daily basis. So now, if we could use the solar panel to charge our phone, to charge our devices, what do I need to do? At first, I need to find out if there is any other devices that are already available in market. If so, with that question, I started to research if there's any current available devices in the market. And what I found was most of the current devices, current solar chargers, are very heavy, big, and totally not too portable in their sizes. And also, most of them are not integrated to this cell phone itself. So with this in mind, I started to look further, and I found two devices that kind of matches to what I was trying to develop, but most of them, again, are a little bulky. As you can see, these are a little bulky, and it's hard to carry around. So also you have USB chargers that uses lithium-ion battery, and again, it's hard to carry them around with your cell phone. Now, my main goal was to integrate the solar panel itself to charge the cell phone entirely on solar energy. With this in mind, I set up some requirement for my senior design, which are as follows. Like, the system shall use solar energy solely to recharge the handheld devices, shall cut off the power supply when it's fully charged, shall only supply the required amount of voltage. If you get more amount of voltage, you know what's going to happen. So, and also, the system shall be thin, portable, and durable so that you can carry it around wherever you go. Now, all the products has an architecture that we have to work on, and this is my basic architecture, which explains, which basically has three more important components, like solar panel, circuit, and smart board. The solar panel acquires solar energy and converts the solar energy into electrical energy, which is supplied to the circuit, which is going to stabilize the voltage and maintain the current, maintain the stable voltage supply to the smartphone right here. And the smartphone is going to use that voltage supply to charge the battery, which are inside the cell phone. So then I went further and thought, well, what can I do next? So again, nobody wants to carry bulky cases. So after a brief search, I found these items that were suitable for my senior design. I had a solar panel right here, 0.3 millimeter case, and this is what I intended my final product to be like. Now I'm looking at small solar panel, and it was very hard to find it. Most of the solar panel was either big. If it was small, the supplied voltage or current were pretty small, and it was hard to use for my senior design. So finally, I found a product that was quite close to what I needed, about 6 volts output and 140 milliamp in current. And also, I had, again, as I discussed earlier, I had a solar panel that would fit in an iPhone charging case of 0.3 mm and a voltage regulator to stabilize the voltage supply. So now I have everything. So I thought I can put that in, I could get the voltage into my iPhone and charge the device easily. So I put a simple circuit to charge my device. But when I did that, it actually failed. It didn't like it. I had voltage going to my device and still didn't like it. So I thought the simple circuit would, work fine, but that didn't happen. So that led me to do further research, and also found out that my USB cable wiring, I had to understand it well. Only supplying positive and negative volts to the device wouldn't work, and I had to take care about the data cables. And also I had to learn some more about the circuit of the cell phone itself, how this behaves. So I think our very good friend Dan Burley is going to talk about this more. Right now I'm more concerned about battery power control, as I'm using this cell phone charging unit to regulate my voltage from my circuit. So this is how a typical cell phone charging circuitry looks like. Again, it's pretty easy, pretty simple to understand, looks like. So now, And looking at this again, as I said, this whole charging circuit is very important because it would prevent your cell phone to cut off the power supply as soon as it is fully charged. Have you ever wondered why your phone was not on fire when you left that on to charge overnight? That's because of this. So, yeah, after looking through all of them, after looking over that very simple circuit, I came up with a complicated circuit, which has few capacitors and a voltage regulator. And obviously a solar panel that will supply voltage to the regulator while I have a zener diode to block the voltage to flow back. So with that, I have 5 volts output from my circuit. Now again, for effective charging, if you look at your adapters, you will see on most of the adapters it will say 5 volts. If it doesn't say 5 volts, there is something wrong, probably. Current required 1 ampere, about 1 ampere, and total power is about 5 watts. So usually it takes about 113 minutes to charge a cell phone, or in this case an iPhone fully. So now I have a new design circuit. So what I need is a setup so that I can start working on my design. So this is how I set up in the laboratory in order to see if it's working well and in order to get the data. I have my circuit set up right here. I have my DAC, which is going to help me in data acquisition. There is a lamp, source of lamp, which is going to act as the sunlight. And in my first test, I found out that there was a voltage sent from the lamp, and the regulating circuit was behaving well, maintaining the consistent voltage output for the cell phone. Moving on, I have this program written in LabVIEW 2012, which would help me do the data acquisition so that I can know what's going on with my data, or if everything is working as planned. Again, we did that on the laboratory. We tested that on the laboratory. It was working okay. I also did a test on a bright day, and found out that the circuit was still behaving right. Now we have 5 volts power supply. That's fine. But we don't have 1 ampere current, and I don't have 5 watt power. Again, as I discussed earlier, this solar panel was able to produce only 140 milliamp of current in total. So that was a challenge for me, which also had a huge effect. That gave me about 1,080 minutes of total charging time, which is almost a day. So not too bad. Anyways, so here's what I did. Again, this is my testing in the laboratory that we set up, and it was working fine. Now, it's working fine, but we need a proof. So I think I have some video to take a look at and to see if the circuit is behaving well. Let's click on the first one. Now, right here, we have the breadboard. We have iPhone, I think, and we have solar panel, and we have a source of light that will act as in solar light. So the solar panel will obtain the light and change that to electrical energy, which in turn supplies that to the circuit. Right here is my circuitry. You can barely see it, I guess. But there are some capacitors and a voltage regulator right here, and the USB cable carries that power output from the circuit to our phone. See if it works well. Oh, it does. All right. Should turn off. Okay. I think, is that good enough? Oh, okay. It says the power is slow. It's charging. Thanks to Betsy. Now the second video is actually showing you the prototype of the solar charging case. As you can see, the charging case is really thin. This is not, fully designed, fully completed product yet. So, this circuit wouldn't be here. It will be a very small circuit. But this is a prototype. I hope you understand. And this is my son. So if you hold your phone to your ear, how does it look like? Just a glimpse of that. So let's play. Disregard my sound. And back up the case, so charger case. Put it down, charging, let's keep charging, So what have we learned? We have learned that this phone belongs to Betsy. But besides that, we have learned that we can use solar energy to charge our devices. As you could see, we could even charge the device under a certain kind of lights, and given certain, you should have favorable situations. Now, but one thing that I couldn't accomplish on my design is the time, the effectiveness of the charging time, which I will be researching on that for my future work. And also, you could see I use that on my iPhone 5. I will also try to incorporate that to other smartphones and available smartphones, so that we can enjoy our phone when we take it to the beach or something without having to recharge it again and again and again, and also saving some energy. So special thanks to Dr. Conley, who helped me with everything, and Bessie James with her cell phone, and all the engineering department. Questions? Thank you.
Any questions for Dinesh?
Oh.
I have a lot of questions. But just from the engineering point of view, you showed that lots of people have tried this, right? There are multiple patents out there.
Right.
And yet none of them are quite commercial yet.
Right.
And yet still in the past year, you've already accomplished this much. So
Right.
my question is, why do you think that there isn't already a commercial product? Why can't I buy this right now? Because you've already accomplished so much more.
Thank you for the question. Nice question. Good question. Tough one too. But again, for my research, I would love to carry this case around. But look at the charging time, 1,080 minutes. That's a long time. So probably we have not come to a way that we could, increase, or let's say, multiply our current supply. If we could have done that, probably it could have been accomplished. So I think people, scientists and myself, are still doing the research on how we could probably get that, fulfilled. Once we can do that, I believe should be available in market soon. Not this one, but
it's already significant enough that it could delay your charging time.
That's correct.
People only charge
That's correct.
another day, and so instead it only has to
That's correct. Now, the other thing that might be stopping it from coming to the market also might be the solar panel itself, because as I measured in the lab, under the light bulb, when I reflected the light on the solar panel itself, it got really hot. So I can only think, it might get really hot under a sunlight, direct contact of sunlight. As you can know, in summer it gets pretty, hot, and any other surface. Besides it's being black, it's a great source of, you can trap the heat easily, and so I think that might be the other reason too. Any other question? Thank you for the question, though. That's great question.
Any other questions for Dinesh?
I'm just curious, the small solar panel you put
Yes, sir.
on there.
Yep.
How much does something like that cost itself? Is the solar panel itself expensive?
The solar panel itself wasn't that expensive. I found that panel for about $7 each. So if it goes on a mass production, probably that was maybe $1 or something, but it wasn't that expensive. But thank you for the question.
All right, thank you, speakers.
Thank you. Thank you.